Hello. You join us here today to talk through and have a walkthrough of the Infrahub Sync project that we at OpsMill have created and are maintaining to allow us to easily transfer data between different platforms. A week or two ago, myself and Mikhail discussed different data silo challenges, and one of the solutions of managing data between platforms was Infrahub Sync. So today I'm joined with Benoît here, who has been active on this project for a long time and done a lot of the features that we're going to look at today. Yeah, feel free to introduce yourself, Benoît.
Hi everyone, so Kohler. I'm working for OpsMill for close to 2 years now, and I'm maintaining the sync as well as some other ecosystem tool like the Ansible collection, MCP servers, Infrahub exporter, and so on.
Yeah, so a lot of knowledge in the Infrahub ecosystem. Perfect. Today, we're going to be looking at how to synchronize data from one platform to another, how to get installed with Infrahub Sync and go from basically nothing, an Infrahub instance that's empty, to populating it with some data from an existing platform that contains data. And that platform we're going to be using today is NetBox. A lot of our customers use both NetBox and Infrahub in the same organization, so the ability to synchronize data between both is very important to them. Being able to have maybe devices defined in one platform and then have other data in the other is very important to them. So a lot of our customers and community members are using Infrahub Sync for that purpose. So let's get into it. We'll start sharing this very technical live stream, so we can be sharing code and going through, working through the problem of having and building a synchronization. So I'll just exit out of this slide and then start sharing my code. Right, so we have an Infrahub instance here. It's been loaded with some example schemas. Anyone that's seen Infrahub before, it is a platform that you build your own schemas on top of. So you define what you would like to see and maintain the data you would like to maintain within our platform. But we also provide the ability to have a schema library where we provide examples for commonly used schemas, everything from devices, locations, cabling. We provide a long list of different extensions, we call them, and some experimental schemas that users are using. So we've just loaded some very basic information, basic schemas from that schema library into Infrahub, and there's no data in the platform. It's totally empty, as if we were starting fresh. And we'll be creating a Infrahub Sync configuration file and showing you how easy it is to bring over data and talking through the different concepts. So first off, I'll go to my VS Code instance that is here, and we can see it in here. We're going to create a new folder called Sync. Let's create a folder called Sync, and that's where we can host our configuration file for this synchronization. Can you give a brief overview, Benoît, about what the configuration file contains and what its purpose is, and why the config file over traditional Python?
What the config file need to contain will be obviously the source and destination. We call, and for that we call them adapters, so like which type of source and which type of destination. Currently, we are able to do it to and from NetBox, Notabot, LibreNMS, Observium, IP Fabric, and Slurpit, to just name a few. So the config file will contain source and destination. It will also contain the mappings we want to do. So as Infrahub, the schema in Infrahub is completely custom. You could have your device name, I don't know, like car for what that matter in Infrahub. So you want to say, okay, let's say the device in NetBox will be a car in Infrahub. Maybe you want to use the slug from NetBox as name in Infrahub. So you do the mapping on the different models and attributes and in which order you want them to synchronize. And while a config file in YAML compared to Python is not everybody we want to sync data to Infrahub is able to do Python or is wanting to do Python. So the idea is to just define this configuration file to do the sync, and the tool will do it for you. You don't have to do extra Python code to define the rest.
Perfect. Good explanation. So what we're going to do is just create a very basic configuration file in here. It is a YAML file. So I'm just going to call it config.yaml. Now, as we can see, Benoît does have access to this file, so he can edit it as well as we go along. And first off, what we need in a configuration file is the name of the synchronization. So we can give the synchronization a name, for example, from NetBox. From NetBox is a good name because that's exactly what, in this instance, what it's doing. If we were syncing to peering manager, you might do a to peering manager. And you can create different names for different purposes, whether you're only synchronizing devices or BGP sessions, for example. Awesome. As Benoît was saying, we now need to define the source and destination. So in our instance, we're going to have a source of NetBox and a destination of Infrahub. And we can specify this with the source. We can give that a name. We'll just give it NetBox. And these names are important because it is the identifier for the adapter that we're using. So if we go into the documentation here at docs.infrahub.app, integrations, Infrahub Sync, we can see these adapters here, and they'll tell you what they are. We're using the NetBox one. So yes, we can already see Benoît's populating some information in there. The settings. Each adapter might be slightly unique in how the settings are configured. So in this instance, the NetBox, we have a URL and a token. The token is our local instance of NetBox. And then in the destination, we have the name Infrahub, which specifies the adapter to use and the URL of where to reach Infrahub. Perfect. So there's another key in there called order. This is very important. Infrahub Sync, as you could imagine with any database architecture, there is potentially hierarchy in the database where some things might need to exist before others because of relationship purposes. You can't add a device potentially without adding a manufacturer or a device type. Like you couldn't add a car without having the maker of the car, because we need to relate that data somehow. So the order is very important to be able to say synchronize one item and then go on to the next and do it in order so that we have the data available. Anything to add there, Benoît?
Nope.
Perfect. And we can see that Benoît's also started adding the schema mapping. So this is an important part to the whole synchronization process. Schema mapping allows you to first define a list of synchronizations, and each of them is given a name. The name in our instance is the destination kind in Infrahub. So Benoît's put in here built-in tag, and that is because we have a node in Infrahub called built-in tag. So if I go to tags, I can have a look at the schema in here. That schema has a kind of built-in tag. So the name references the destination of where it's going. Mapping is pretty important. That shows where it's coming from, the data that is being pulled from. In this instance, it's using NetBox under the hood, and this is what's required to get the tags. It somewhat aligns with the API of the NetBox API. So for example, I can go here, go to API, and then I think it was extras, and then tags, and we can see the list of tags in here. Now tags are part of many objects in our NetBox database at the moment. So we want to synchronize those first, and that's why the order's there. Identifiers. Can you provide some information on identifiers, Benoît?
So during the sync, we need to know what will be the different, I will say, unicity constraint you may want to keep. So for example, in NetBox, you may define name as unique. That doesn't mean in Infrahub that would be the case. So for that, you need to define if it's only one attribute, it will be the identifier, or if you have several attributes. Of course, in the case of a bullet or a tag, maybe not, but let's say for a device, you could have an identifier, which is not just the name, but as well the site and the name, because you will define unicity constraint, in like per site. So you could have the same device name, but based on the site, it will be fine. But if you have two on the same site, it would be an issue. So for that, you can define here what will be used as identifier for during the sync to define which node is unique when we are linking node between them, especially.
Perfect. Do you want to cover the fields as well?
Cool. So the field is, I will say, quite simple in this case. On the name directly, we will define the name at the destination. So in this case, in Infrahub. So our built-in tag model of a name and a description. So name will be the one we used here. And the mapping will be, again, the one coming from the source of, so in NetBox. In this case, we have in NetBox the field name, and we will map it to the attribute name in Infrahub. The same way for description, we match description to description. In the example I was saying before, we could decide to say, oh, I want actually to map the slug from NetBox as name in Infrahub, and that will be how you will do it.
Perfect.
But in our case, we'll do on the name first.
Yeah, this is a very one-to-one mapping here. And then we'll get into more complex things later on. So we've saved that file. And what I'll talk through now is just how to get set up with the Infrahub Sync project. So I'm using UV to manage my virtual environment. So we do UV add Infrahub Sync. That will add the dependencies. I've already got them installed here. So I will go into my virtual environment. There we go. And we should have access to the sync command line. If I do Infrahub sync --help, we'll be able to see this command line utility has 3 different commands. It has a list, diff, generate, and sync. And the 3 of them all do different things. So because we are very simple to configure using the configuration file, under the hood there's a lot of complex things that are happening. We're using a platform called diff sync to be able to do the differentiation between 2 platforms. And to do that, we need to build some Python constructs to be able to do that. But we make it easy and make it simple to use by running the Infrahub generate command. So I can go into this here. I think it's Infrahub Sync generate. And there'll be some more configuration file options in here for the CLI. So first we want to specify the name of the synchronization, so that we're doing from NetBox. And then we can also specify the directory, for example, and we're using the sync directory. And when I run that command, what it will do is generate the adapters for each and the models for each of the source and destination adapters. So in my folder on the left-hand side now, we can see there's an Infrahub Sync adapter that has some information for the built-in tag, as well as a model that defines the model that we currently have defined in our config file. What's important to note is if you do change the config file, we just regenerate using the same command, and then we can do a synchronization. Anything to add, Benoît?
No.
Good. Right, so we'll get into the next command. If we just, instead of generate, we do diff. What this will do is start running the synchronization process, but without actually applying anything to Infrahub. So we can see here, it loaded data from NetBox, it loaded data from Infrahub. It didn't have anything in Infrahub, so that's pretty simple. And then it showed us how many objects there were, 26 in this instance, and it will show us if there is a change. So we can see here that built-in tag alpha is missing in Infrahub. And if we use the sync command instead of diff, it will apply that diff to Infrahub. What's good about this is because Infrahub is branch aware, we can have different branches. I can create a branch called livestream. That'll create a branch in Infrahub. And then as part of my diff command, I can then attach the branch option and then specify live stream. And anything it does, it will go and fetch information from the branch. If we do sync, it will sync information to the branch. So I'll just apply this one first. Infrahub sync. Same thing at the end, I specified the branch live stream, and I can do the diff, which it's done, and now it starts pushing those changes to Infrahub. So completed in 4.6 seconds there. If I go to my main branch in Infrahub, we can see if we go to tags, there's no data. And if we go to our branch that we've pushed the changes to, we can correctly see the tags have been synchronized. Perfect. Should we talk through adding the next part of the configuration file? Benoît, you can go through that.
Yes, one of the elements we want to synchronize from NetBox will be, I will say, anything related to tenancy and groups. So obviously, again, because we want to have the group before we want to have the tenant, we would first add the group in our order. So in Infrahub, we are using the core standard group, which is directly part of the built-in and core type of schema. And I will just, so here we will have name, kind of standard group, mapping with NetBox piece. So tenancy that it's tenant and group with a S. We keep our identifier simple in our case, which is still the name. And again, the field we want to sync. So name for name. The name on Infrahub, it will be linked to the name in NetBox. We want to keep the description as well. Mapping description. Should I directly add the providers then? Let's do that. After having the group, we would directly be able to synchronize our tenancy. So in our case, we just want to synchronize it as provider type. And then same thing as provider type of object. Name, and I can just copy paste this because it didn't change. And here I can add up our provider up. And with this, we will be able to synchronize the tenancy group and the tenant associated with it.
Perfect. Shall we run that? Let's go through the process. So for anyone using this, again, we need to generate the underlying models and adapters. So we just use the generate command. If we use the diff command with the branch, we'll be able to see that there's more going on now. If I scroll up, so we can see that we loaded the tags, we loaded the tenant groups, the tenants, and we can also see we pulled the tags we already synchronized before from Infrahub, but there's no groups and there's no organization provider. And we can see here now it's providing us with the diff again for the core standard group and the organization profile, the organization provider. It's perfect. We can see it's synchronizing good, the diff's good, and we can apply this to our branch by just specifying Infrahub Sync with the sync parameter, and that will apply those changes to Infrahub. And if I go to, let's say, my groups, we can see customers has applied here. And if I go to the organization provider, we can see that the organizations have also synchronized into this branch. Perfect. What I will do is what we want to start looking at is more complex synchronization. So I'll just put in some additional synchronization for sites. So we're going to start doing sites, very one-to-one mapping. I'm going to synchronize site groups to the standard core standard group like we did before. And then we're going to start looking at synchronizing some sites over. So we can see if we just go to our NetBox instance, that NetBox has the ability to have regions as well as sites. So regions, which is like, for example, Asia, with Asia has China included. And then as part of some of those regions, you also have sites. And those sites belong to regions. So it's very hierarchical. Infrahub is very similar. We can provide hierarchical nodes, and we can provide locations, country, metro, sites, for example. So we need to somehow fit the data from the regions into the correct node in Infrahub. So, for example, location, we might want to add a country first and then add a metro area, for example. So I'm going to talk through a way of being able to do this. So first off, we want to synchronize the countries. So we might want to do location country. The mapping where we'll get this from is dsim site groups, no, regions, sorry. The identifiers for this is name, and then we'll be looking at the fields. So first off, what do we want to bring over from NetBox? We want to bring over the name, the slug, and potentially the tags that are applied to those. This is where we'll touch on a new topic of being able to create relationships using Infrahub Sync. So I'll just put this in here. So name will be mapping name to name. In our instance, we have a short name in Infrahub. So if I go in here and look at country, we have short name, description, time zone, and things like that. So I'm going to be synchronizing short name. For this, I'm just going to be doing the slug for now. So that's not one-to-one. And then the last one, we're going to synchronize tags. So the destination relationship in Infrahub is tags. So we can see here, it's tags. And what we want to do is map this over. And in NetBox, they also define their tags within the tags object key. But the key difference here in the Infrahub Sync configuration is how we define a relationship is using reference. And what we do is refer the tags to the kind that was previously synced. So this is where the order is very important, and that will be built-in tag. So what this is saying is when we pull those tags, see if we have that already synchronized from when we synchronized tags before, using the identifier as the key. So we're going to synchronize tags. And now, very important is the filters. Filters allow us to filter the data from a source. Sorry, not field. Filters. And this is a list of objects. And what we want to do is specify what we're filtering on. So because in NetBox it's hierarchical, Africa is a depth of 0. If I actually just go to the API here, we'll be able to see this. Africa, for example, has a depth of 0, meaning it's at the top of the tree, and then anything that comes under it will be a depth of 1 with its parent. So we can see here China, for example, we can see China has a parent of Asia and the depth is 1. So we're only synchronizing countries here, so we're not doing the top level region, we're doing the countries. So we want to filter out and only look at and synchronize items with a depth of 1. So, oh yeah, Benoît has populated, so we're going to be looking at the field depth _ depth. The operation is equals, and then the value in this instance of what we want to match, which will be 1. There are other, if I just go to the Infrahub Sync, there are other operations that you can perform. So if I look at schema mapping, and then we look at fields, mapping filters, we can see field operation value, and then just under that we have the list of available filters for that operation. So we can do equals, not equals, greater than, less than, contains, not empty, etc. So you can be very specific about what we want to synchronize into Infrahub. Perfect. So if we do the same again, we generate the models, we do a diff just to validate the data, and then we should see the two things that we added: the core standard group, which is going to synchronize headquarters, customer sites, branch offices, as well as the countries. And we can see we've skipped the regions. We're only synchronizing the countries here: China, India, Singapore, etc. Perfect. And I can apply that with the sync. So I'll just push those changes, and then we'll be able to see in Infrahub those values. So if I go to location, country, I can now see on the left-hand side, I've got my countries, and we can see here we've got the different countries as well. If there are hierarchical nodes, which we'll see on the next synchronization, if we add the metro, when we start adding more data to this into the hierarchy, we'll be able to see these will turn into drop downs and things, and the UI will change slightly. Do you want to go through the next part of adding the metro and the sites, Benoît?
Yes, before that, I just want to indicate something you have in your diff. If you scroll back up.
Oh, yes.
On the NetBox call description, so on the call standard group, you have a change on description. So while Alex was speaking, I changed description in NetBox for the customer group. Something which is important is we don't synchronize the objects all the time. We are able to synchronize just the diff. So in this diff, you don't only see like if they are missing or not, but as well what changed. So for example, here was a new description on NetBox side. If you have a change of description on NetBox and in Infrahub, you will see as well like, okay, it's not the same on both sides. And based on some extra parameter, you could choose which one you want to keep.
Awesome. So if we edited it on the Infrahub side, we'd also see what Infrahub represents here. So it would overwrite it. Very nice. Yeah, that's very good.
The next step will be the metro. So adding them in the order. We want to have the metro and we want to have the site. So location metro will be the same as country. You will have the same name, parents, short name, system. The only difference is in this case for metro, we will indicating a reference for the parent. So because here we use the slug for the mapping with as reference with a short name, we will have as well here when we are referencing the country, we will reference it based on the parent slug. And
that dot, what's the dot doing?
It's a sub-element of parent, so it will access, like on the parent, you will access the attribute of the parent. So here for the parent, you have ID, URL, display, name, slug, and depth. So you will go, we will use slug and not name in this case.
Perfect. Awesome.
And last but not least, I need to add the filter because we are now still linking region. Oops. Okay. So we keep the same head, but now we have a value of 2 for the depth when we had 1 before.
Awesome.
Let's do the site as well. So for the site,
very similar to the metro there.
Yeah, so here for the site, we are not linking it to DCIM region anymore, obviously, but to DCIM site. We are using the short name as identifier, which is still mapped to the slug, name for name. Site, we still have a parent, because in Infrahub, you still call a parent in this case on our hierarchical node. And we do the mapping to the region. So as DCIM site, we'll have a region instead of the parent. So we use region.slug on NetBox from NetBox, and we will link it to the location metro on the Infrahub side. And we can as well add more reference. So here to the organization provider type of object using the tenant from NetBox, and of course the tag still.
Perfect. So if we save this file now, we'll be able to generate, and let's explore the data. And I'll just go straight to the sync and push that data. So there's a lot more data now. We're getting up to synchronizing 126 things. Perfect. Now if we look at that hierarchical node we saw before, so if I refresh the page here, we can see United States has turned into a drop-down option, and that drop-down option will now show the metro areas within that country. So we can see the hierarchy is working fine. If there's any tags, they get added, which is good. And we can see that if we go to like Alabama, the parent is correctly mapped to the United States. It's perfect. The next part of the synchronization will touch on a new topic, which are transforms. So I'll go into the configuration here, and we'll start looking at synchronizing racks. So we have racks here. I'm synchronizing to the location rack node within Infrahub. We're coming from DCIM racks using the short name again for the rack. We're going to put the rack in a site using the site slug. In our instance, it'll be in the hierarchy, so we're using parent. And very one-to-one. The thing we have different in here is we need to do some transformation of the data. The data doesn't map directly from NetBox into Infrahub. And that can be a challenge sometimes. In the formatting doesn't work properly. For example, we have the height in our schema library for a rack as an integer, whereas in NetBox it's a float, because you can have 1.5 of a rack, for example. So what we need to do here is be able to transform. No, we use, this is a different one. Sorry. We're transforming the short name in this instance, actually, calculating our own short name. And what transforms do is they allow you to create a dynamic field. So we're creating a new field called short name. This short name didn't exist in the NetBox data before, but we can create a field called short name, and then we can apply an expression to create that short name field. And in this instance, it's just a ginger. So in here, we can reference the site slug to underscore in this instance name, and then replace any spaces with underscores, just so we have a unique name, because we need to map this field correctly for the unicity of Infrahub. So I will generate again and sync, and then if I go to my racks location rack There's no racks in there at the moment. It's just going to synchronize them in. And we'll be able to see what the transform did in that instance. There we go. If I refresh the page here, so we can see the short name ended up being the site slug, and then the comms closet, the name of the rack. And without this, because Infrahub in our schema library, you could change this in your schema library. I was just getting it to match. Is that our uniqueness constraint is only on the short name. In this instance, you might actually want to have parent as well as short name, for example, for unicity, but I kept it as the default schema library, which is creates that uniqueness, because if we didn't have that uniqueness on the short name, we would get comms closet, comms closet, comms closet, and it would only ever create one, because there's only one to create, because there would be overlaps. Perfect. Right, I'm trying to find the next one. I think we could skip through a little bit and go straight to device types, where we have another transform, and then Benoît can talk about that. So I'll just put in the schema for device organizations and platforms, which you've seen before. It's kind of one-to-one mapping as we've seen. And then feel free to do the device type, Benoît.
Sure. I can keep adding it in the order. So for the device type, so it will be closer, I will say. So we have still some, I would say, keep the similarities, description, part number. We have quite similar naming on several. You see still some change of difference, il full depths to full depths, and model from NetBox to name. So everything is coming from the device type model. We adding, I will keep add some before going to the interesting piece of transform. The manufacturer, we're using the manufacturer name coming from NetBox to link it to the manufacturer model, which got added by Alex. And in similar way, we do the platform name to link it to the DCIM platform, which Alex just added now. The interesting piece will be for the height. So as Alex said, in our schema, we are not using, I would say, float for the rack unit, but directly integer, like big int in our GraphQL way. So we cannot store like a device type, which is one virgule five, like 1.5 U or 2.5 U. So what we're doing here is we're creating an extra field, will be integer height, which is the one we use here in the mapping. So this one is not the one coming from NetBox. It's the one we're creating with the transform. In the transform, we are using the one from NetBox, UHeight. And we just run it up to the closest. So if it's 1.5, it will go at 2. And if it's less, it will go at 1. And I will let Alex run up the sync, and then we will be able to check on Infrahub Sync and on Infrahub and on NetBox the difference, as you will be able to see a proper transform.
Perfect, so that's completed. We can then go to NetBox here, go to racks. Oh no, we're on device
Device
type.
type.
device type.
We have one which is not a full.
I think they're all whole. They're all whole here. we can edit this. If I edit one, and I can make it. Oh, there you go. Like it's 1.0. If I change it to 1.5, go back to my device types, because the U height 1.5. I'll just quickly run that sync again. We should see in the diff as well when it pops up that it's going to change that. See, we can see the NetBox is 2 and Infrahub's 1. Because of the transform is rounding it up, and we already synchronized 1 into there. I think we might have an idempotency issue on Metro at the minute. We can look at that later. So yeah, 1.5 in here, it was AP7901. If I go to device, device type, and go to AP7901, because it's been rounded up to 2. Perfect.
Ta-da!
Ta-da! Yeah.
On top, on some of those transform, you have some other obvious one as well, like lowercase, uppercase, and other specify change.
Definitely. That allows you to do some quite important things during synchronizations. Is you might need to clean up data during the process, and that might be a good opportunity for these transforms to do that for you. So maybe lowercasing all of your host names, or ensuring your data is formatted in the correct way when it enters Infrahub. That's quite important. You can also do a few things like combine multiple fields together, for example, an IP address and a subnet mask into a valid IP address that might need to be entered into Infrahub. That could be other ways to use transforms, but we see it used quite widely. Anyone familiar with Ginger will be able to create transforms and utilize them. Any questions, by the way, feel free to put questions in chat, and we should be able to see them and answer them, as there is only 10-20 minutes left. And the last one we have is to synchronize the devices. Obviously, we can go further in depth, but the last one we have is to synchronize devices, where we combine a multitude of things. We're going to, again, do some one-to-one mapping. There is some relationship that's being added as well for device type and platform, location, tags. We can also see we're using a transform again for the position within a rack. We're using that round function as well. And also we're filtering. Maybe we don't want all the devices to be synchronized into Infrahub, because you might want to use NetBox to store PDU information and things like that. We only want to synchronize network devices in this instance. So I've got a filter on here, operation regex, and I've just got a regex that's valid and will match just the network devices that I'm focusing on. That's because we might be using Infrahub for different purposes and might synchronize different data, but it means you can pick and choose what data you want to synchronize. You don't have to sync everything. Generate that again, perform the sync. There we go, it's synchronized. Did it synchronize? No, and the reason why is because we haven't added it to the order. So I don't know if I've been showing this part of the screen, but Benoît has been adding the kinds to the order as we're going. So for me to synchronize devices, I just need to take the name of that, add it to the order, and then we should be good. And then we can look at the idempotency issue that we're having with locations. So what's happening is it keeps on thinking there's a diff between Infrahub and NetBox, I think. So it keeps on saying there's a diff for Metro. So we'll figure that. So it's pushed the devices now. If I go to devices, now if we look at the devices, it's all colorful. We have roles applied, we have device type relationships, we have platforms, which is all good information because it's added to a location. Yes, the transform worked well in supplying those heights, and it looks quite good. Perfect. So let's have a look at this. Any questions? Again, feel free to put them in the chat and we'll pick them up. So we have an idempotency issue on location Metro. How might we try and look into this? So it might be because we have something being used. So let's look in Infrahub and see what the uniqueness constraint is. So we'd go to schemas, location, and we'll look for the Metro. Uniqueness constraint is short name. So what I'm going to put in here is identifier short name. This might get it. Oh, it's the parent. So NetBox is US.
We're using the name on the country to be
Country,
the identifier.
yes. Yes, we are.
But in your schema, it's still short name.
It's a short name. So if we go to, oh, I'm on the wrong one here. If I go to location country, yeah, and we change this name. So you can tell that here. So if we go to the diff, we can see it's saying United States. We want this to show the short name, which is short name. That one. Oh, I need to do the generate again and then sync. There we go. It says there's no diffs now between the two platforms. So it's synchronizing one-to-one and it's in sync. If we change any data for any reason, so if I go into here, let's go into this one here and we change the description, for example. Let's put something in there. And then I won't do the sync, but if I do the diff, are we synchronizing the, what did I add in here? I did the description for a site. Let's make sure we're synchronizing site descriptions. No, we're not. So I can add that in. Name, description, mapping, description. Generate again. Perform the diff. There we go. And it will tell us that NetBox has nothing and Infrahub does, which is good. Perfect. So it'll show us the diff. You can keep things in synchronize. If you want to just get a diff, you can run just the diff. If you actually want to push data, you can. Now, finally, we've made all these changes in a branch. When you're happy with testing out your synchronization, you can then, of course, publish it to the main branch. You can either do two things. You can open a proposed change and go add NetBox data to Infrahub. That will create a proposed change, which will have a diff associated with it. You'll be able to see the difference. With Infrahub Enterprise, you'll be able to have this to be enforced, to be peer reviewed before it can be merged. So you can have that traceability and checks in there to make sure that the incorrect data doesn't get synchronized. So the proposed change is just running some tests in the background to make sure that everything is happy with the synchronization. It's just doing the schema integrity. If we look at the data, we can see all the diffs within Infrahub between the branches. So we're adding data to the main branch. So we've got greens everywhere. We've got no changes. We can easily see, although the tool is showing us what the diff is, we're also providing a diff on the Infrahub side to be able to see the difference in data. So once all those checks are complete, when you're happy, if you've got Infrahub Enterprise, obviously there's a whole peer review process that you can have enforceable. But when you're happy, click merge, and data will be then merged into your main branch. So we'll wait for that to complete, and proposed change has been merged. I can then go and delete my branch if I want. So I can go in branches and delete that branch. But if I look, I'm on my main branch now. If I go to devices, perfect. We have synchronized data from NetBox into Infrahub, and it all looks good. Some key concepts there to take away. So yeah, anything to add, Benoît?
No, you went through most of the explanation. What's interesting here is we don't only synchronize data to Infrahub, but as well data from Infrahub to the source of truth.
Yeah.
So we take the example of Ping Manager before. It's possible to then get data from NetBox to Infrahub. We can get as well a push to Ping Manager afterwards, for example, and then you can link all your source of truth together, so you have one common pot, even if the data came from different source of truth at the beginning. So you have a better way to consolidate it.
Perfect. That's great. Well, thank you for attending our live stream on the Infrahub Sync topic, and we have some more live streams scheduled soon. Keep your